Hi, Evergreen. Let's do Chapter 6, Lesson 5, the angles of a triangle. So let's go over some things that we already know, but just to summarize that we're going to use on this lesson. Theorem 20, the angle sum theorem, all three angles of a triangle add to 180 degrees, always. Corollary number 1, if two angles of one triangle are equal to two angles of another triangle, the third angles are equal. So if you see two triangles and angle A and D are equal, and they have a second angle that is the same, E and B, you know that it is going to have an equal third angle, F and C. Corollary number 2, the acute angles of a right triangle are complementary. So we know that this is 90 degrees, our right angle, and we need a total of 180 degrees. And so therefore, this acute angle plus this acute angle will add to another 90 degrees. And so these are each 45 on a right triangle. Corollary number 3, each angle of an equilateral triangle is 60 degrees. So equal sides, equal angles. 180 divided by 3 is 60 degrees for each equilateral angle. Theorem 21, we've already learned this, but this is also something we're going to use today. The exterior angle is found. So we have the triangle. We extend one side of the triangle. This exterior angle outside of the triangle is found by adding these two remote interior angles. So let's dig in. We are going to do some problems together. Numbers 1 through 18. So, corollary proofs. Let's use our corollaries to prove what's going on. Complete the following proofs of the corollaries of this lesson by giving the reasons. The proofs are written in paragraph form. So, corollary number 1. If two angles of one triangle are equal to two angles of another triangle, the third angles are equal. So we know this is true. So it says we have triangle ABC and triangle DEF, and it tells us that angle A is equal to angle D and angle B is equal to angle F. We need to prove that angle C is equal to angle F. So, number 1, prove that angle A plus B plus C equals 180 degrees. So those are the three angles inside of one triangle, and angle D, E, and F are equal to 180 degrees. And those are three angles inside of another triangle. So we are going to use our proof that the sum of the angles of a triangle is 180 degrees. So it follows that A plus B plus C equals D plus E plus F. And why? Substitution. Because A is equal to D, B is equal to E, and therefore C is equal to F, substituting each for the other. Now number 3, because A equals D and B equals F, it follows that D plus E, sorry, I lost my place, plus C, so D, E, C, so these are our angles D, E, and the C unknown. Well, we could find it out, right? And then D plus E plus F. D, E, F equal the same thing. And why? Substitution. What we just figured out up in number 1, we're substituting for that. And then therefore C equals F. And why? Subtraction. We could add D and E and subtract this total from 180 to find F. And the same for angle C. Great job! Corollary number 2. The acute angles of a right triangle are complementary, meaning they add to 90 degrees. Given triangle ABC is a right triangle with the right angle being angle C. Prove that angle A and angle B are complementary. Now, number 5. Triangle ABC is a right triangle with right angle C, so right angle C equals 90 degrees. Why? Because a right angle equals 90 degrees. This is I just feel like we're writing the same thing. It means the same thing, right? Okay, 6. Angle A plus angle B plus angle C equals 180 degrees. Yes, we know this is true, right? And so therefore it follows that angle A plus B plus 90 equals 180 degrees. What did they substitute for angle C? 90 degrees are known, and so therefore we used substitution. And so angle A plus angle B equals 90 degrees. Yes, because if 180 degrees minus angle C is 90 degrees left over, then that means angle A and angle B have to share those 90 degrees equally, or not equally, right? And it equals subtraction, right? We used 180 degrees minus 90, subtraction. And so therefore, angle A and B are complementary because they add to 90 degrees. Their sum of the angles equals 90 degrees. I think these are pretty easy. Corollary number 3, you're doing awesome. Equilateral triangle. Each angle of an equilateral triangle is 60 degrees. Each side is also equal to all these sides are equal, right? Okay, so given triangle ABC is an equilateral, prove angle A is 60, angle B is 60, and angle C is 60. Okay, so let's look at this. Triangle ABC is an equilateral, so it is also equiangular. And why? Number 9, an equilateral triangle is also equiangular. 10. Because triangle ABC is equiangular, angle A equals angle B equals angle C. Why? Well, the equiangular triangle has 3 equal angles. Number 11. Because angle A plus angle B plus angle C equals 180 degrees, it follows that angle A plus angle A plus angle A, well, the same thing as 3A, angle A, equals 180 degrees. What did they do? They substituted A for B and A for C. Number 12. So angle A equals 60 degrees. Why? Well, we have 180 divided by 3, which equals 60. And so it follows that angle B is also 60 and angle C is also 60 degrees. Why? Substitution with 12. Now that we know that angle A, we know that B and C also equal 60 degrees. Let's practice our exterior angle theorem. One way to prove Theorem 21 is given here. Complete the proof by giving the reasons. Theorem 21. An exterior angle of a triangle is the sum of the remote interior angles, just like we talked about, right? So this angle at exterior equals angle A plus angle B added together. That's what it says right here. And this is what we also have to prove. Okay, so through point C, draw a line parallel to AB. Oh, now we're looking at some 2 parallel lines and a transversal. Do you see this? Let's look. AB is one line, and line L is our second line. These 2 lines are parallel. That's why they have the red arrows. And then AD is our transversal. Very cool. Okay. So therefore, do you notice some things about this? We know that angle 2, where is its angle that is in the same position? Where is that called? A corresponding angle. So 2 right next to the right of the parallel line and above the transversal. Here's our parallel. To the right of the parallel line above the transversal. Angle A is going to be equal to angle 2 because of the corresponding angles, correct? Yes. And this angle across, angle 1, will be equivalent to angle B. But do you know why? Okay, so let's dig into this. Through point C, draw a line L parallel to AB. Why is this possible? Well, it is possible because through a point, not on a line, there is exactly one line parallel to this line. So they must have drawn a line and replicated this angle. See what they did? Okay, 15. Angle 1 is equal to angle B. Angle 1 is equal to angle B. And why? Parallel lines form ulterior alternate interior angles. You see how they're both inside of the parallel lines? And you see how they're alternating? Yes. 16. Angle 2 is equal to angle A. Angle 2 is equal to angle A. Why? Parallel lines form equal corresponding angles. 17. Angle BCD equals angle 1 plus angle 2. Well, do you see this angle and a ray between it? It is the betweenness of rays theorem. So if a ray is dividing an angle, we have 1 and 2 parts that add up to the entire angle. And then therefore, BCD equals A plus B. Why? Substitution. We know A equals 2 and B equals 1. And right here before we said angle 1 plus 2 equals angle BCD. Okay, nice work. Y'all are the best. I hope you have an amazing day. Bye.